Hello everyone, this is lesson 11.7, volume of pyramids and cones. So in the last lesson you learned how to find surface area and volume of pyramids and cylinders, but today you're just going to learn volume because actually finding surface area for a cone is actually quite difficult. So we're not going to do that in this lesson. We might do that after air testing, but this is all you need to know for now since air testing is coming up on the last Monday and Tuesday of April. So that's about 7 weeks away. Plus you have a spring break between there, so that's like 6 more weeks of school. Anyways, so the cone fits inside a cylinder so that their bases are the same and their heights are the same as shown in the diagram. Calculate the volume that is inside the cylinder but outside of the cone. Give an exact answer. So the formulas you're going to need to know for today, we'll backtrack a little bit, are the volume of a cylinder, the volume of a cone, because you already did volume of a cylinder. Well, I'll start off with volume of a cylinder. As a reminder, is pi r squared h. And really that's 3 dimensions. R squared times h would give you a cubic unit since you have 3 different dimensions going on here. Now the volume of a cone is similar to this. It's 1/3 pi r squared h. I don't know if you've ever seen those tutorials where it gives you a cone and you put water into the cone, and if you fill up the cylinder with equal height and base, you would use 3 cones to fill up a cylinder. Therefore, the volume of a cone is 1/3 the volume of a cylinder. Okay, and then prisms are similar to that as well. So volume of a prism is area of the base times the height. The volume of a pyramid, which only has one base and then at all sides all intersect up at the point, the vertex at the top, is 1/3 area of the base times the height. So it kind of works out the same way. All right, so here, one thing we could do is figure out the whole volume of the cylinder and then the volume of the cone and subtract them. But if we know the relationship between them, that 1/3 relationship, we could just say, well, the rest of it is going to be 2/3. So we could do 2/3 times the volume of the cylinder. So we'll do 2/3 times pi. R is 5. So r squared times 12. Okay, type that in your calculator. And you get 2/3. Oh, it says to give an exact answer. So that means we're going to not include the pi. So I'm going to do 5 squared is 25 times 12, and then that times 2/3. Well, you could do this in your head. Divide by 3, multiply by 2 gives you 200. So that means 200 pi and units cubed. I don't know what the units are here. Okay. A square pyramid has a volume of 245 inches cubed. So let's go ahead and draw what a square pyramid looks like. So this is how I like to draw it. So you got a square base that's kind of slanted because, it's 3 dimensions. And then you have the height of the pyramid. I like to draw like a little dotted line here. And then the height is, remember, the altitude, so it goes perpendicular to the base. So I like to draw a little perpendicular symbol. And then I'm actually going to use a line tool so that I can make it nice and precise. You can always use a ruler or a straight edge. And then you would draw little lateral heights up to the vertex. Okay, this is a square base. So that means whatever this side length is, same thing as this. So it has a volume of 245 inches cubed, and the height of the pyramid is 15. So this height here is 15 inches. What is the area of the base of the pyramid? What is the length of one side? Okay, so this is actually super easy. We know the volume is 245. It's equal to 1/3 area of the base times the height, which is 15. Okay, so really we're just first, so we're solving for the area of the base, and then whatever we get, since it's a square, we're just going to take the square root of it. Okay, so 1/3 times 15 would give us 5. If you divide by 5 on both sides, 245 divided by 5 gives you 49, I think. Let me double check. Yeah, that sounds right, because 250 divided by 5 is 50. Oh, wow, I did not even, okay, it's 49. Okay, so 49, area of the base, and that would be inches squared. Okay, so that makes our life easier now, because then the side length would just be 7. So that's the square root. Okay. Okay, an example with the cone. Okay, determine the volume of the cone shown below. Give an exact answer. All right. So for volume of a cone, remember we want 1/3 pi r squared h. The problem is we know what h is. This would be the lateral height, which you don't use in the formula, but we'll need to use that to figure out what the radius is. Okay, so we're going to do r squared plus 11 squared equals a square root of 137 squared, which is just 137. 11 squared is 121, so if you subtract 121, you get r squared equals 16. So that means your radius is 4. Okay, so that worked out nicely. So now let's do volume equals 1/3 pi times 4 squared would be 16 times 11. So 16 times 11 is that. Can we divide that by 3? Nope. So we're just going to write 176 pi over 3. That would be the proper way to leave it as an exact answer. Volume, so units cubed. Find the dimensions of a cone that is similar to the one given above. So if you wanted to find the dimensions of a cone that's similar, you would just need to pick a different radius. So really, pick any radius. Well, actually, let's pick a scale factor first. So let's say our scale factor is 2, which then means our radius would be 8, and then our height would be 11. Okay, so 22, because the other one was 11. So let's do, and then the lateral height would just be 2 times the square root of 137. So volume would then be 1/3 times pi times 8 squared is 64, and then times the height, which is 22. So 64 times 22 . Oh, well, that just asks for the dimensions. So actually, I think that answers the question. And then calculate the volume of a cone that you described in 2 different ways. So use the formula and the scaling principle for volume. Okay, so if we use the formula like I was just about to do, that would be 1408 pi over 3. Now the scaling principle for volume, remember if we're double the radius, or if we double the scale factor, then what are we doing to the radius? We're doubling it, but what are we doing to the volume? So if I take the volume that we found in the first part, which was 176, and I divide that from 1408, I get 8. So actually, your scale factor, remember how your scale factor for area is squared, your scale factor for volume, you would need to cube it to find the volume. Okay, so if we were to simplify this and get a decimal for part C, we would cube whatever we got there, and that would be how we'd get our answer. Okay. All right. And then for this one's actually pretty easy, and I think to save some time, I'm just going to leave that in the Edge Elastic assignment. right? So that is all for today. You guys have a great day.